We've got section 3.4 today, day one, properties of log functions. You'll be able to prove properties of logarithms algebraically, use the properties of logarithms to expand and condense. There really shouldn't be a star there. I'm not sure why the star doesn't, that star exists there. It should be taken out. Use the change of base formula, graph logarithmic functions of base b, and re-express data when seeking a model for the data. You guys familiar with Kepler's law? You've used it in physics. That's the re-expression problem we do. But this is over the next couple days. We'll get to the change of base formula today. Okay. Properties. Oop, I've missed that bottom part. The properties we'll get to. But we have logarithms have a special algebraic traits that historically made them indispensable for calculations and still make them valuable in many areas of application and modeling. Reminder, logarithms are the inverse of unknown exponential quantities. Therefore, we use the properties of exponents for logarithms as well, just to help us find, what our graph is. And we can use that inverse idea by switching the x and y values. And if we graph an exponent and switch it, we're graphing the logarithmic version of it, okay, for its inverse. Now, if I'm talking about properties of logarithms, we got the product rule. And this product rule, this is important if you notice, product rule, quotient rule, power rule. It's all about multiplying or dividing. You notice that? When I'm actually using a property of logarithms, I have something that's multiplied, like the factors inside the product rule. I've got log of base b, and that's true for log base 10, log base 2, log base a half, or the natural logarithm. We'll represent those differently. We'll introduce them in a different way, but it's the same flavor when I'm talking about product rule. If I have two factors, r and s, okay, they're multiplied together. The log base b of r and the log base b of s will be added together. It'll be the same as the log base b of r times s. But you got to think about what the result is. You're talking about exponents, right? So that makes sense that I'd be adding the exponents. And when I'm looking at the quotients, I'm still talking about exponents. I'm talking about the log base b of r and the log base b of s still. And I'm finding the difference of the exponents. And when we did this, when we were doing exponents, or we worked with the division of exponents, we take the exponents of like bases, and we take, like in this case for our quotient, x minus y, to find out what it was. And that's what we did here. That's the idea of it, the basis. But that's why we subtract the top from the bottom. Okay, it's an about division and multiplication when we apply these rules. The power rule, if I have a log base b of r to the c power, okay, c drops in front, okay, we're raising it to that value, so we're just multiplying our exponent, whatever our value of our exponent is, times c, okay, just like we would with the power rule. So there's a connection with it. There's a reason why we're doing those things. Now notice the first property of exponents is used to verify the product rule for logarithms. Now we're going to check this out. We're talking about the product rule, and this is what they want me to prove. In order to do this, I got to do a setup, and I purposely did it this way so I could be consistent each time. I taught 2 classes. I'm random enough to come up with a different way to do something each time, so that's why I do it this way. I'm saying that I'm going to let x represent the log base b of r. Okay, so I'm going to have x be there, and I've got y here. So keep in mind that b to the x power is r, b to the y is s when I have this setup. If I look at this snail rule, the snail shell, b to the y value equals s, b to the x value equals r. Now, if I set that up and I get to this next part, I know right now, based on my just working with r and s, and the powers that I defined, that r times s is equal to b to the x power times b to the y power, because b to the x represents r and b to the y represents s. Now, in this next step, I'm looking at it and it seems to make sense that I can combine my exponents that way. okay? Because if I have two bases, same bases, multiplied together, I could get to add the exponents. Okay, well, if I take the log to base b of both sides, I'm now looking at the situation where log base b of rs is equal to log of b to the x plus y power. And using my properties, I'm able to do this next step and say, well, since I have the log base b of b to the x plus y power, I now know that that's right side is just x plus y. And remember how we evaluated, or I should say defined x as being the log base b of r and y being the log base b of s? I'm just going to substitute those in here in the problem. Now, this is a proof of how the product rule for logarithms, kind of works. It's not a problem I'm going to have you guys do on a test. Okay, just like when I did the derivation of the quadratic formula using the completing the square on ax squared plus bx plus c equals 0. Okay, I didn't have you do that on the test. It's something I showed and how it exists. But some of the things that I want you to be aware of as we're looking at these, exploring the logarithm arithmetic, there's a connection to the powers and the things you multiply. So grab out your calculator, take that out, and we're going to work on each one of these problems. We're going to kind of take and step through 1 and 2 and 3. But I want you to start paying attention to what's happening with our powers and how we can interface with logarithms with our calculator and how they're connected to exponents. So I've got the log of 2 times 4, okay? And that should be the same as log of 2 plus the log of 4. Okay, because remember, the log of 2 times 4 it becomes 8. It should be, this is log base 10 we're working with. If it was in log base 2, that would just be a 3 return. But since it's log base 10, it's a different value. So what I want you to do is recognize that if I plop in the log of 8 in my calculator, then I put in the log of 2 plus the log of 4, it should return the same solution. So I got the log of 8, it's 0.90309. Okay, the log of 2 is 0.30103, and the log of 4, which is, remember, 2 squared, okay, should be double that, 0.60206. Okay, and since 2 times 4 is 8, which is 2 cubed, okay, that log of 2 that we did should be 3 times, 3 times the log of 2 should be 2 cubed, and it works. So it's a neat connection to be able to see that, that's the connection with our logs, and it's all about exponents and how we deal with exponents with exponential functions. Now, if we look at the quotient, okay, we got 8 divided by 2. Okay, and we all know it's a log of 4, we're looking at, and if we're talking about not natural logs, but common logs. And I'm looking at log of 8, okay, which is 2 to the third, and I'm going to subtract off log of 2, okay. Well, if I take one of them away, I've got 2 left, and ideally that should be 4, so it should be 0.60206 when I'm done. Okay, so I have this number sense working with logarithms. It shouldn't be like, ooh, I put it in the log in my calculator and something happens and this comes out. But it's never the same and it's always just this magic thing. I just don't understand it. It shouldn't be that. We should have a really decent number sense of what's happening with our logarithms when we're going to plunk on our calculators and get a value out. Now in 3, I'm looking at the power and how that's going to work. So if I do the log, the common log, base 10 of 2 to the third power, that should be the same as 3 times, okay, and remember 2 to the third power is 8, and I've been kind of referring to 8, that those powers, or 4, 2 to the second power, 8, 2 to the third power, and looking at the actual value we had for the log of 2 and being able to manipulate it to get to those other answers. I already know the log of 2 is 0.30103. Well, 3 log of 2 should be 0.90309. Okay, as I look at that, and that's what I should be getting. So as I'm working with them, I should start making sense to me about the exponent connection. Now, is it helping, this setup as I'm looking at it to just kind of think, hey, this is how that they're interfacing. So if I'm looking at this one, I've got a fact that 5 is equal to 10 over 2. That's the log of 10 minus the log of 2, okay? If I am able to evaluate that. So I've got the log of 10 over 2, and that represents the log of 10 minus the log of 2. So I've got 1 minus 0.3013. Well, that should be the same as the log of 5, my result, okay? As I look at my calculator, as I kind of explore with it and figure things out. Now, in 5, they're asking me to use the fact that 16, 32 are powers of 2. 16 is 2 to the 4th power, 32 is 2 to the 5th power, and 64 is 2 to the 6th power. Now, they're asking me to evaluate the log of 16, the log of 32, and the log of 64. I'm pretty confident to say that the log of 16, which is 2 to the 4th power, is going to be 4 times 0.30103, because that's the log of 2, and I'm just multiplying it by 4. And the log of 32 is 5 times 0.30103. Okay, it should work through that, being consistent with, I already know that base of 2. So when I'm looking at that, I've got that going on. I multiply it by 4, I get 1.20412. But that's all I'm doing. I'm exploring, I'm learning about how those properties that we went through work. But please notice that it's the product rule. I'm multiplying the properties, and I get to show that I'm adding my exponents. The quotient rule. I'm dividing my factors, right? I'm dividing my factors, and I subtract the exponent, and it makes sense. Okay, and then we got the last through the power rule. Okay. Now, my last one, they say evaluate log of 25, log of 40, and the log of 50. Well, I've got the 5, I've got the 10, I've got those going on. So I got 2 times the log of 5. We got the log of 5's up here, which is, this should have been equal to 0.69897. And that's where I got my log of 5. Okay, because 10 divided by 2 is 5, and we got the log of 5 going on there. So I've got that. But I didn't get those other ones in there yet. So I've got the log of 32 and I got log of 64 down here. And I got my 40 and I got my 50 going on here, just so you could see what was going on with them. Okay. Are you okay with the relationship that they have and the consistency that they have? It shouldn't be that, oh, I'm going to put something in my calculator. I'm going to use the natural log or the log, and I don't have a really good feel for the answer it's coming out. I mean, you should have a pretty good estimate. If you got a base of 2 and you have the log of 9, well, 9's more than 8, so your value should be more than 3 coming out. Okay, because 2 to the 3rd power is 8, so 2 raised to the 30 point something power is 9. Okay, so be kind of aware of what's happening with the number that's going to come out, and so you have that idea of number sense. Okay, and I'll just drag my feet a little bit as we're going here, but make sure that you notice the connections there. Now, part of the stuff that we kind of just unraveled a little bit is expansion and contraction. Okay, because you can look at a logarithm, and based on the information provided, you can expand it out using the properties, and you can condense it down using properties, and that's what we're going to be doing in problems 2, 3, and 4 those examples, just to practice that. Are you guys okay? Just want to make sure everybody's got it. So when we solve logarithm equations algebraically, we often have to rewrite expressions using properties of logarithms. Sometimes we expand, sometimes we condense to solve. Now, in example 2, I've got you expanding. And assuming x and y are positive, use properties of logarithms to write the log of the quantity 8x y to the fourth as a sum of logarithms or multiples of logarithms. So the first thing I've got going on here for myself, I mean, I could break this down a little bit, but I've got the log of 8 plus a log of x plus a log of y to the fourth. That's my first line. Log of 8 plus a log of x plus a log of y to the fourth. They're all multiplied, okay? So just like any dutiful student thinking about, okay, I've got my 10 is my base for my exponents, right? And I'm finding what value is my exponent that I'm going to add and still have my base 10, because it's a log base 10 I'm working with. So this exponent plus this exponent plus this exponent based on those values. This one has 4 up here. I can bring the 4 to the front. Okay, and I can also factor out the 8 to be in 2 to the third. But I did that first. I was going to go for the 4 on that, but whether you do it the way I did it on the board, the way I was going to talk about it, it doesn't matter. So long as your final result is going to be the answer. So what I'm going to do next is the 3 is going to drop in front. The 4 will drop in front. This one's already done in the middle. And that's my total expansion. Now, be comfortable with expanding. You will be assessed no calculator-wise expanding. And your calculator just doesn't expand for you. Okay, so be comfortable with it, and it just won't be adding and expanding. Okay, we're going to be doing some funky stuff. So we're going to be subtracting, we're going to be adding, we're doing some square roots with it. I'm just going to make sure people have it. Go ahead and look at this next one. And remember, don't try to do it all at once when you first see it. Just do parts of it. That help you go to the next piece. A lot of times people want to do it all at once and they make little mistakes. And I will ask you to do it all at once eventually by the end of these notes today. But assuming x is positive, use properties of logarithms to rewrite the natural log of the square root of x squared plus 5 all over x as a sum or difference of logarithms. Well, the first thing I'm going to do a difference. I've got the natural log of the square root of x squared plus 5 minus the natural log of x. And that square root has a power of 1/2. So I put that power up there right away. Now, I'm going to take that half power and put it to the front. Okay, just like we did on that previous thing that, hey, that's 2 to the third power. I can just take the log of 2, multiply it by 3. That was putting it to the front. And when I get to there, I'm done. Because remember, I cannot break this down any further because of the plus sign in between them. All the rules we've applied have been multiplied factors or divided factors, or I'm doing the power of a power, squaring with it. It's all about multiplication and division. It's not about this. I can't break this piece up any further than it is. That's what I'm talking about right now because of the plus sign. Okay. So I'm done. This is expanded. Now, condensing is just the reverse. And gee, I'm just going to have it done for you, apparently. I thought I had it all cleaned up and everything, so we're just going to talk about it real quick. Maybe. Things are never working when I want it to. Okay, so let's go back and we'll come back. When I'm doing this expansion part, assuming x and y are positive, write in the natural log of x squared minus 2 times the natural log of xy as a single logarithm. Now I've got this going on, and I got a little sloppy there. I really like to have that parenthesis around those. Okay. This subtract means I've got a division issue. going on. So I've got this happening, and I've got this up here, the first thing. I've got that to go there. And then I got my division issue to clean up. So I got the natural log in front, x squared, x to the fifth, and I've got xy squared, so I just went x squared and y squared and distributed those. Carlson, you okay with what I did? Don't look at the board that mean anymore. Okay, I'm just giving a hard time. Are you okay with what I've done? Are there any follow-up questions? Because these two extra examples, I want you to try. Okay, you're going to expand both of these. Now the first one, I got 3 times 5. They are factors. So I've got the natural log of 3 plus the natural log of 5. Done. You okay with that? I got the natural log of 4 times x times y. So I should have the natural log of 4 plus the natural log of x plus the natural log of y. But now, this 4, I can break it down to powers of 2. Okay, so I've got that broken down. And really, if I was truly going to expand, it should be 2 natural log of 2 plus the log of x plus the log of y. Are you doing okay with what I'm doing? Any secrets about it? Go for a condensation. Condense. C. Go for a condense. Sorry to pick on you. It's just, you're like, okay, so here's the deal. I got the natural log of 4x plus the natural log of 3x plus natural log of 2. So I got 4x, the natural log of 4x times 3x times 2. Okay, so I got those inside. So I have 4 times 3 times 2, which is 24. I've got x times x, which is x squared. And that should be there. And we doing okay, feeling all right with this so far. Okay, now I promise, condensing, expanding will be quizzed / tested on. Okay. Why in the world did I have that? Sorry, apparently I did not clean up very well. Oh, I know why I have that, but I also can't figure out why it's still on the page. Okay, so now expand A and B, and then I'm going to have condense the next one as well. Okay, these are just practice, just to see, how things are going, to get better at it. On this one, lean left and right to check those 3, A, B, and C. I know I got a couple A, B's, and C there. This first set, let's call this 3, A, B, and C. And let's call this 4, A, B, and C. And D. Apparently that I've got done for you, but why did I do that? I'm just going to leave the answer there, I guess. We'll talk about that. So after you're done with that first set, that number 3 A, B, C, and D, or A, B, C, excuse me, please check with somebody around you what they got. Okay, so I should have the natural log of 4 minus the natural log of 3 here. And then on this one, I should have the natural log of 7 minus the natural log of 6 x, but oh, I think I took care of that one. Good. But I should also be pulling the x out too. As I look at that, you could also, I suppose, you could have also written this one this way. And I'm not sure why I did that L the way I did, so let's fix that. Does that make sense? Either one of those would have been okay. Because I just distributed that negative. It's up to you. Now, in this condense, I got that negative outside. And that's kind of funky. It looks like I'm dividing everything out, but why would that be? As I'm looking that over, you know, we've got this going on here. If I can move that up. I've got that over 1, but what's a log of 1? Log of 1? 0. Okay, so if I had this in front, maybe perhaps everybody would have been okay with it. But then I've got the natural log of 1, or the log of 1, okay, because that's returning an exponent value, remember. So if I have that 1 out front, that would be great. Because I suppose I could have had the log of 1 minus the log of 3 minus the log of x minus the log of 5x prior to that, and then I could have distributed that out and recognized, well, I've got this. Okay, as I step through that in my head a little bit, okay, because it looks a little spooky when I see that negative right away. Are you okay with kind of the steps just to put it down to the condensed version? Any questions? Now expanding. Natural log of 2 to the third would push me to say 3 the natural log of 2. I should have 2 the natural log of x. I've got to condense in this next one. So go ahead, do 4C, D, and then go for the expand in one big step without breaking it down. Try it. Yeah.
So, for this one, this is right?
Mm-hmm. Yeah, it is. That is the right answer. I just wanted to make sure that some folks, when they saw that negative, they're like, where in the world do you get the 1? That was my concern. That's why I showed you these steps to get to that next one. I should have been more clear about that. Thanks for that follow-up question, Ms. Johnson. Now, these are great questions for a non-calculator type situation because, you know, you don't need one. You just condense, you expand to get them done. You okay with what I'm doing with my powers? X squared, 3 squared. I could talk about that being 9, by the way. So my next step might be and will be natural log of 9x squared over y to the 4th. Doing okay there? Now, compare your expanded version with somebody around you. Now, let's try to kick that back. I want you guys to compare before we check it with me. Okay? Compare your expanded version with somebody around you. Just give it a try. If you need to, if you can't do it in one big step, do an intermediate step. It's okay. But talk to somebody else, compare your solution to somebody else's. No? No beating on you? Try that. It's okay. Let's break it down a little bit. Now remember, everything on top is subtracted by the stuff on the bottom, right? Okay. So my first intermediate, and I don't think I have enough room because I know how long it is. My first intermediate is I have log base 7 of 5x squared, and I am probably going to write this in a bracket right away. Oh, excuse me, 2 to the third power. So, excuse me, 2 divided by 3 power, because that's my root. 2y1 minus log base 7 of this stuff is all in one bracket, really. And 2y x plus 1 to the 1/2 power. Are you okay with my first attempt? First part of the attempt? Okay, because I had some people when I was walking around, it's like, Bloom, I have no idea. I'm okay with that. But are you okay with why I did what I did when I did it? There? Reason? Okay, you have those. Okay, now, I'm just going to stay with the front side first, and then I'm going to go to the back side. Okay, so I'm going to stay on the front, and keep in mind I've got the log base 7 of 5 plus the log base 7 of x squared. And I've got plus, the log base 7 of the quantity 2y minus 1 to the third power. I haven't broken those powers to the front yet, right? Is there any questions about what I did on those first three terms? Three terms. We okay? You okay? You have that look at me like you're mad at what I wrote, okay? And it's like, whoo, you put it in its place. Where'd it go? No, but are you okay with the fact that since they're factors, I get to break them up as separate log terms that with plus signs, okay? So that's why I've got the log base 7 of 5, log base 7x squared, and then I've got this piece here inside. Remember, this is a power. It's not just a fraction. Now I've got this subtract. Now, be careful with the subtract, because this is supposed to subtract everything inside here, okay? So I'm going to kind of put a little subtract over there. By the way, I'm subtracting this, so that continues down in this next line, because I'm not going to have room unless I do this. So on this other step, I've got minus a parenthesis, because all this stuff is going to be multiplied by a -1 when I'm done. Log base 7 of 2 plus the log base 7 of y plus the log base 7 of x plus 1 raised to that 1/2 power. And then I got to finish my parenthesis slash my brackety looking parenthesis, because all that's got to have a negative distributed. Okay? Are you okay with my expansion? so far. Now, what I'm going to do in my next one, I'm going to take those powers, I'm going to drop them to the front, and I'm going to, I'm going to put it's 2 log base 7 of x. That's going to be 2/3 log base 7 of 2y minus 1 minus log base 7 of 2 plus log base 7 minus, log base 7 of y minus 1/2 log base 7 of x plus 1. That's what I'm going to write in this next line because it's already written for me. Okay. So the blue's the final answer, expanded. Okay. And notice how I broke everything down. If I had things like 8s or 16 or 32 or 27 and I was able to break those down as powers, I would do that as well. It's very nitpicky. If you're careful with your notation, you can write it as in one fell swoop or just as you're looking at it. That's an expansion. Try condensing this next piece. We will finish the remainder of this problem tomorrow. We'll do the condense and multiple fell swoops and then simplify. Have a great day.